The Secret Life of Raindrops. Rain, the untold story. Rain is one of the oldest companions of life on Earth. It has watered our fields, filled our rivers, shaped our landscapes, and written itself into our myths and memories. Without it, civilizations could not rise, and with too much of it, they could easily fall. Rain is both a blessing and a threat, a cycle of life that humankind has never fully controlled. There's an old proverb that says, "When the sky cries, the earth lives." Every drop falling from the clouds is more than just water. It is part of an ancient system that sustains the planet. It refills aquifers and lakes, feeds crops and forests, and cools a world warmed by the sun. In a way, each raindrop is a messenger from the sky, a link in the endless circulation of the water cycle. The origins of rain. To understand rain, we must go back to Earth's violent beginnings. Over 4.6 billion years ago, our planet was a hellscape of molten rock, hotter than the surface of today's sun. It took 600 million years for Earth to cool enough for vapor to condense into liquid water. What followed was extraordinary, a rainstorm that lasted nearly 3 million years. Imagine skies filled with endless dark clouds, lightning splitting the heavens, and torrents of water pounding young continents day after day. This ancient deluge gave birth to oceans, lakes, and rivers. It carved valleys and filled basins, creating the watery world we now know. Today, 71% of the planet is covered in water, yet only a tiny fraction is drinkable. Out of the 326 million trillion gallons of water on Earth, 97% lies in salty seas, 2% is frozen in glaciers and ice sheets, and just about 1% is fresh, liquid, and available to sustain all life. That 1% is precious beyond measure. It is constantly recycled through the water cycle, evaporation from oceans and plants, condensation into clouds, and precipitation as rain or snow. Without this circulation, ecosystems would collapse, agriculture would end, and humanity would vanish. The secret life of raindrops. Though we see rain almost daily, its details remain surprisingly mysterious. What exactly is a raindrop? Where does it come from? The story begins with something invisible, a speck of dust, salt, or smoke drifting in the air. Water vapor condenses around this particle, forming a tiny droplet within a cloud. Millions of these droplets collide, merge, and grow until they are heavy enough to fall. The shape of a raindrop is not the teardrop of popular imagination. Small raindrops are nearly perfect spheres, sculpted by surface tension. As they grow larger, air pressure flattens them into a shape more like a hamburger bun than a tear. Very large drops can even split apart midair. Their speed depends on size. Fine mist drifts lazily at 1 to 2 meters per second, while larger drops can race downward at 10 meters per second, over 35 kilometers per hour. Instruments called disdrometers take 55,000 pictures per second to measure raindrops as they fall, capturing their size, shape, and velocity. This helps meteorologists interpret radar images and understand storm dynamics. Even today, scientists admit they cannot fully answer a simple question: how big is the raindrop that just hit your head? Rain and civilization. Rain has shaped human destiny as much as kings and wars. Entire empires have risen in fertile valleys fed by seasonal rains, only to collapse when drought struck. Ancient Mesopotamia flourished between the Tigris and Euphrates, nourished by floods and rainfall, while civilizations in Central America and China recorded centuries of hardship when the skies withheld their gift. Caves in Asia still preserve inscriptions carved during terrible droughts. Farmers, monks, and travelers etched warnings: no rain for months. Crops failed. Families starved. These silent voices from centuries past remind us that rainfall is not just weather, it is survival. In China, prolonged drought in the 17th century contributed to famine and rebellion, hastening the fall of the Ming dynasty. Across the globe, similar stories echo. The collapse of the Mayan civilization in Central America is linked to centuries-long droughts. The Sahara itself was once a green, rain-fed savanna before climate shifts turned it into desert. The monsoon's power. Nowhere is the drama of rain more visible than in the South Asian monsoon. Each summer, winds carry moist air from the Indian Ocean across the subcontinent, unleashing weeks of torrential rain. For farmers, this is both salvation and threat. A weak monsoon can mean famine. A strong one can bring catastrophic floods. To prepare, governments and scientists monitor the monsoon using satellites and climate models. A single accurate forecast allows farmers to plant drought-resistant crops or conserve water in advance. Dam managers release reservoirs before floods arrive, while cities brace for inundation. In countries where hundreds of millions rely on rain-fed agriculture, getting the prediction right is a matter of life and death. Measuring the unmeasurable. Humans have tried to measure rain for thousands of years. The first rain gauges appeared in ancient India and Korea over 2,000 years ago. Farmers used simple jars to measure depth and plan harvests. Today, the tools are far more sophisticated. Automated gauges use lasers, sensors, and pressure systems to detect even a millimeter of rainfall. Amateur weather watchers still keep traditional copper gauges in their gardens, sending daily reports to meteorological services. These thousands of volunteers provide valuable data, complementing the high-tech readings from satellites and radar. Their careful notes are translated into a universal code, a language of weather symbols used worldwide. Each code marks the type of clouds, the strength of wind, and the timing of rainfall. In this way, a farmer in Ireland and a scientist in Japan can read the same data and know the sky's story. The space age of rain. The real revolution came with satellites. Before 1960, forecasting meant studying surface weather, scattered balloons, and pilots' reports. Then the launch of Tyros 1, the first weather satellite, changed everything. For the first time, humans saw Earth's swirling clouds from space. Huge storms that once arrived as a surprise could now be tracked days in advance. Today, fleets of satellites orbit the planet, many dedicated to watching rain. They use microwave sensors to peer through clouds, distinguishing drizzle from downpour, snowflakes from hailstones. Some, like the Global Precipitation Measurement Mission, combine international data to build a near real-time map of rainfall across the globe. This information feeds into supercomputers, which run billions of calculations to simulate the atmosphere. The results help predict not just tomorrow's weather, but the likely patterns of rainfall decades into the future. The future of rain. As the climate warms, rainfall is becoming less predictable. Storms are growing more intense, droughts more prolonged, and weather patterns more chaotic. Areas that once relied on steady seasonal rains now face either violent downpours or eerie silence from the sky. Understanding rain has never been more urgent. Scientists are racing to decipher its patterns, governments are planning for water security, and communities are learning to adapt. Whether through advanced satellites or simple copper gauges, the quest is the same: to understand the language of the rain. The eternal companion. Rain has been with Earth since its earliest days and will continue long after humanity is gone. It is a timeless traveler, circulating from sea to sky to land in an endless rhythm. Every drop that falls carries with it the memory of primeval storms and the promise of future harvests. To listen to rain is to hear the heartbeat of the planet itself, a song of renewal, survival, and connection. And though we may never fully master it, we will always depend on it. Rain is not simply water falling from the sky. It is the thread that binds together past and future, land and sea, life and death. It is Earth's oldest story, and still one of its greatest mysteries.